Imagine for a moment you took a credit card, something completely flat, two-dimensional, and somehow all the information about you, your life, your memories, your dreams, was encoded on that flat surface. Seems impossible, right? But what if I told you that the greatest physicists in the world believe something exactly like that might be happening with our entire three-dimensional universe? That you, I, the stars, the galaxies, everything we know as three-dimensional reality, might just be a holographic projection of information encoded on an incredibly distant, two-dimensional surface. Welcome to Cosmic Frontiers, Cosmic Explorers. I'm your guide on this extraordinary journey through the mysteries of the universe. And today, we're diving into one of modern physics' most revolutionary and mind-bending ideas, the holographic principle. Get ready to discover how our three-dimensional reality might literally be a cosmic illusion created by two-dimensional information. By the end of this video, you'll never look at the space around you the same way again. And who knows, after understanding this, you might even question if you're truly touching this screen, or if it's just a holographic projection of data on a distant cosmic frontier. We're on an incredible journey towards 1,000 cosmic explorers, and every discovery we make together brings us not only closer to that goal, but also to a deeper understanding of the cosmos we inhabit. Let's start our exploration with a fundamental question. What exactly is a hologram? You've probably seen holograms on credit cards or security stickers. When you move the card, the image appears three-dimensional, as if it has real depth. But in reality, all that three-dimensional information is encoded on a completely flat surface. It's like someone took an entire 3D object and managed to flatten all its information onto a sheet of paper, but in a way that still preserves all the dimensional details. Now imagine that on a cosmic scale. The holographic principle suggests that our entire three-dimensional universe, the stars, the planets, every atom and every particle, might be a holographic projection of information encoded on a two-dimensional surface located at the farthest boundary of the cosmos. It's as if we live inside a gigantic cosmic hologram, where every pixel of information on that 2D boundary contains data about immense volumes of three-dimensional space. But hold on, before you think this is science fiction, I need to tell you that this idea was proposed by some of the most respected physicists in the world. Leonard Susskind, from Stanford University, and Gerard T. Hooft, a Nobel Prize winner in physics, developed this theory based on discoveries about black holes. And here's where the story gets really fascinating. Consider this. When you throw something into a black hole, what happens to the information that object carried? For a long time, physicists thought that this information simply disappeared, was destroyed forever. But this created a gigantic problem called the black hole information paradox. In quantum mechanics, information cannot be destroyed. It's a fundamental law of physics. So, where did this information go? The answer came from a revolutionary discovery by Stephen Hawking. Black holes emit radiation and eventually evaporate completely. But if the black hole disappears, where does the information from the objects that fell into it go? Susskind proposed a radical solution. The information never actually falls into the black hole. Instead, it gets imprinted on the surface of the event horizon, the boundary of the black hole, like a kind of two-dimensional hologram. This is where your mind might start to break a little. Imagine you're falling towards a black hole. To an external observer, you would never actually cross the event horizon. Instead, your image would become frozen on the surface, as if it were printed on a two-dimensional screen, carrying all the information about you. To that observer, you would literally become a two-dimensional hologram on the surface of the black hole. But if this works for black holes, why wouldn't it work for the entire universe? That was the brilliant question that led to the development of the cosmological holographic principle. Juan Maldacena, another brilliant physicist, took the next crucial step with the ADS-CFT correspondence, which mathematically demonstrated how a quantum theory in 4 dimensions can be completely equivalent to a gravitational theory in 5 dimensions. Let's translate that into more understandable terms. Imagine you're watching a 3D movie at the cinema. On the screen, you see characters, objects, and scenes with apparent depth. But all that three-dimensional information is actually encoded on a two-dimensional surface. The screen, the ADS-CFT correspondence, suggests something similar for our universe. Our three-dimensional reality might be like that 3D movie, a projection of information that is actually encoded on a two-dimensional screen located at the boundaries of the cosmos. Now you might be thinking, but I can touch things, feel textures, move through three-dimensional space. How can this be a projection? That's an excellent question, and the answer takes us to the heart of quantum mechanics. At the quantum scale, touching something isn't exactly what it seems to be. When you put your finger on a table, the atoms of your finger never actually touch the atoms of the table. What you feel as solidity is actually the electromagnetic repulsion between the electron layers of the atoms. In other words, even our most basic experience of physical reality is already, in a way, an illusion created by quantum forces and fields. If the holographic principle is correct, this illusion would be even deeper. Every interaction you have with the world around you would be the result of information processing on the two-dimensional boundary of the universe. It's as if you were a super sophisticated character in a video game, interacting with an apparently three-dimensional world that is generated in real time by an incredibly advanced two-dimensional processor. But here's a question that will make you pause and reflect. If this is true, would it change anything about your life experience? You would still feel love, still have dreams, still make discoveries and create memories. The difference would only be in the cosmic hardware that sustains our reality. Instead of being fundamentally three-dimensional, it would be fundamentally two-dimensional, projecting a 3D illusion so perfect that it would be indistinguishable from true reality. This idea has profound implications for our understanding of quantum gravity, the holy grail of modern physics that tries to unify Einstein's general relativity with quantum mechanics. If space is truly holographic, this could explain why gravity behaves so differently from the other fundamental forces. Perhaps gravity isn't a real force in the traditional sense, but rather an emergent property of how information is encoded and processed on that two-dimensional cosmic surface. It could also explain some of the deepest mysteries of the cosmos, like dark energy, that mysterious force that is accelerating the expansion of the universe. If our three-dimensional space is a projection, perhaps dark energy is simply a manifestation of how new information is constantly being added to the holographic screen of the universe, creating more projected space. It's important to emphasize that the holographic principle is still a developing theory. According to our current understanding of physics, we have solid mathematical evidence that it works in specific situations, especially related to black holes and in certain spacetime geometry. But whether it applies to our observable universe is still an open question in frontier research. Scientists around the world are working to test this idea in various ways. Some look for holographic signatures in the cosmic microwave background radiation, the oldest light in the universe. Others investigate how information behaves in simulations of quantum black holes. And there are those who are trying to detect if there are fundamental limitations on the amount of information that can be stored in a region of space, which would be direct evidence of the holographic nature of reality. Imagine for a moment the magnitude of this discovery. If confirmed, it would mean that every thought you have, every memory you form, every dream you dream, would be the result of information processing on a two-dimensional surface so distant that light would take billions of years to travel to it. You would literally be a holographic projection of cosmic data, but a projection so rich and complex that it possesses consciousness, free will, and the ability to contemplate its own holographic nature. This also connects us to other profound questions about the nature of reality. If we live in a holographic projection, does this relate to discussions about whether the universe might be a computational simulation? Perhaps both ideas are pointing to the same fundamental truth, that what we experience as physical reality might, in fact, be a sophisticated form of information processing. Recapping our cosmic journey today, we discovered that the holographic principle suggests that all the information of our three-dimensional universe might be encoded on a distant two-dimensional surface. We learned how this idea emerged from the mysteries of black holes and the information paradox, and we explored how this could revolutionize our understanding of quantum gravity and cosmic mysteries like dark energy. But perhaps the most fascinating aspect of all this is that, even if we are holographic projections, this in no way diminishes the beauty and meaning of our existence. In fact, it might make it even more extraordinary. Think of the cosmic elegance required for two-dimensional information to create such a rich projection that allows not only the existence of conscious beings, but beings capable of discovering their own holographic nature. This leads us to a profound reflection on our place in the cosmos. If we are truly holographic projections of information on a distant cosmic frontier, then every human being is a unique and unrepeatable manifestation of universal data processing. Every life, every consciousness, every moment of scientific discovery like this would be an expression of the universe's ability to know itself through its own holographic projections. Cosmic explorers, I have a question for you in the comments. If we definitively discover that we are two-dimensional holographic projections, would that change how you see the meaning and purpose of human life? Your reflections always enrich our collective journey of discovery. And speaking of discoveries, what universe mystery do you want me to talk about in the next video? Wormholes, multiverses, the nature of time. Leave your suggestions in the comments. Our next cosmic destination might be exactly what you're curious to explore. We're on an incredible journey towards 1,000 cosmic explorers. If this video expanded your view on the nature of reality and sparked your curiosity about the deepest mysteries of the cosmos, join our crew by clicking subscribe. Together, we are pushing the frontiers of human knowledge about the universe. Like this video if it made you question the very nature of reality, and share it with someone else who also loves to get lost in the depths of cosmic mysteries. After all, if we really are holographic projections, may that projection be as curious and discovering as possible. In the next video, we'll explore another concept that will blow your mind about the nature of space and time. Until then, keep looking at the stars and questioning the nature of reality. Even if it is a two-dimensional holographic projection disguised as a three-dimensional universe,